Hello students. So let's revise today three-dimensional geometry. Okay. So first thing which we have in 3D geometry is direction cosines and direction ratios of a line. Okay. So direction cosines are given by L equal to, if you have direction ratios say ABC, then direction cosines are given by cos alpha, then cos beta and cos gamma. Okay. So cos alpha is given by a upon root of a square plus b square plus c square. Same way for m and same way for n. Okay. Then we have a relation between the direction cosines of a line, that is L square plus m square plus n square equal to 1, or cos square alpha plus cos square beta plus cos square gamma is equal to 1. Okay. Next we have equation of a line. Okay. In space. So it is given by, so we have a say line in 3D space. Okay. A is the position vector, that is we have a line say like this. And this is our A. This is R. And there is one more line which is parallel. Okay. So this equation is given by in vector form R is equal to A plus lambda B. Okay. In Cartesian form, it is given by x minus x1 upon a upon c. Okay, where a, b, c are the direction ratios. Then we have an equation of a line passing through two given points. Then this becomes x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. Okay, in vector form it is r a plus lambda b minus a. Okay. Next we have angle between the two lines. Okay. Two lines. So cos theta is a1 a2 plus b1 b2 plus c1 c2. This formula is very important. 1 mark questions or 2 mark questions are asked based on this formula. Okay, then we have two conditions for this. If theta is 90 degree, then a1 a2 plus b1 b2 plus c1 c2 is equal to 0. If theta is 0, then the two lines are parallel, right? Then a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. Okay. Next is shortest distance between the two lines. This is given by d equal to b1 cross b2. These are parallel vectors. Dot a2 minus a1 upon b1 cross b2. Okay. When the lines are parallel, that time this b1 and b2 becomes equal, right? So it becomes b cross a2 minus a1 on b. Okay. Then we have a plane, equation of a plane in a normal form. Okay. So equation normal form. So suppose you have a plane, say like this. Okay. X, Y, Z. Then there is a vector R, okay, and normal vector. This is the distance. Okay. Then the equation is given by r dot n cap equal to d. Okay, n is the normal vector. So, and r is the position vector. So we have in the Cartesian, it is mlx plus my plus nz equal to d. Okay. Next is angle between the two planes. Okay, suppose equation of the plane is given. This should be like this. A2, B2, C2, D2. Okay. Then cos theta is given by A1, A2, B1, B2 plus C1, C2 upon root of A1 square, B1 square plus C1 square, B2 square plus B2 square plus C2 square. Okay. Next we have angle between a line and plane. Okay. It is given by sin theta or phi. You can take B dot n magnitude. Okay. So this is the angle between a line and a plane. So we'll solve some problems. Okay. Let's solve this question. The line x minus 3 upon 1 equal to y minus 6 upon 5, z minus 4 upon 4 intersects the plane at point P. Find coordinates of point P, angle between the line and a plane, distance of point P from the origin. Okay. Now here the line is given and the plane is given. Now this line is intersecting this plane at some point. Say it is passing through it. Okay. So this line and a plane both are intersecting at some point P. Okay. Let the coordinates of point P be x, y, z. Okay. Now we have to find first the coordinates of point P, then angle between a line and a plane, okay, and distance of point P from the origin. So first you have to check whether this line is given in the standard form or not. That is x minus x1 upon a, y minus y1 upon b, and z minus z1 upon c. Okay, so this x1, y1 and z1 you have to check for it. Now this is given in the standard form, so no need to worry. Okay. Now this we can find the coordinates of P using this line and this plane. Okay, let's write x minus 3 upon 1, 5, z minus 4 upon 4. So a point on this line will be x, y, z, right? So we can equate this to some lambda. Okay. So we'll get x equal to lambda plus 3, y equal to 5 lambda plus 6, and z equal to 4 lambda plus 4. Okay. Now this point is passing, that is on this part of this plane, correct? So we can substitute x, y, z in this plane. Okay. So that we get the points lambda. We get the value of lambda. And that lambda we have to substitute in x, y, z. Okay. That will be our point P. Okay. So substituting in plane equation. So we'll get lambda plus 3 plus 5 lambda plus 6 plus 4 lambda plus 4 equal to 3. Okay. So this is 10 lambda 13 equal to 3. So 10 lambda equal to 3 minus 13 minus 10. So lambda is minus 1. Okay. Now you have to substitute this lambda in this and you have to find x. So x is minus 1 plus 3, which is 2, y minus 5 plus 6, 1, z minus 4 plus 4, 0. So this point is our p coordinate, that is 2, 1, 0. Okay. So first one is done. Coordinates of the point P. Let's go for the second. That is angle between the line and a plane. Angle between the line and a plane is given by sine theta equal to b dot n upon magnitude of p, magnitude of n. Okay. Now here b vector is what? B vector is our parallel vector. Okay, in the equation of the line. So b vector is this 1, 5 and 4. So b vector is 1i plus 5j plus 4k. Okay, and n vector is 1i plus 1j plus 1k. This is from plane, normal vector. Okay, let's substitute here. Root of 1 plus 25 plus 16 is 1. Dot product 42. This will be 6 into 7. So 3 you can take out. Root 14 into root 3. Okay. So theta is sine inverse this value. Okay. Next we have to find distance of a point P from the origin. So our point P is 210 and origin is 0, 0, 0. Okay. So distance will be what? Using the distance formula. OP root of x2 minus x1. So there is here it is 0, right? You can directly write this. 4 plus 1 root 5 units. Okay.